So it's a pleasure to have Justus Uitermark with us online, and he's going to speak about the limits of complexity and beyond complexity. Yes. Please go ahead.
Thank you, Jay. Thank you for the invitation. Yeah, as you can see, I had some difficulty deciding on the title of my talk, and at first I chose as a title "The Limits of Complexity," but then I realized that this is a 101 marketing mistake. Obviously, I shouldn't emphasize the negative, I should emphasize the positive. So instead of talking about the limits of complexity, I thought I talk about how we can move beyond complexity and the complexity perspective in the social sciences. Now, before I get to the substance of my talk, I want to say something about my background and my position in relation to complexity sciences and computational social science. So my background is in geography. I was trained as a geographer at the University of Amsterdam. Just to be clear, it's social geography. So I specialized in understanding cities, understanding urban policy, understanding segregation. Then I reinvented myself as a sociologist, a relational sociologist. I especially use theories by Norbert Elias, Pierre Bourdieu. Those sociologists are mostly qualitative sociologists. They use some quantitative techniques, but they're known as comparative and historical sociologists. So I think that I represent sort of the social sciences, and especially the more historical, comparative, qualitative side of the social sciences. And that is obviously important for my talk today, since it gives insight into my specific perspective. It also means that I'm slightly out of my comfort zone in this particular group. So bear with me. So at some point, I developed an interest in computational social sciences and complexity. The reason for this is that I was studying debates, public debates, and I wanted to find a way to map these debates. At this point, I got in contact with Jeroen Bruggeman and Vincent Traag, and I talked with them, and they developed a method that allowed me to map public debates, and especially to examine power relations in debates. Now, I was enchanted by this. I was enchanted by network analysis, and I also thought it was very exciting that they developed a new method to understand public debates, specifically one that also incorporated negative relations, not just positive relations. So this set me on a track of working with computational social sciences, and I've done that ever since, for about the last 10 years. So very recently, I've been working with Petter Turnberg, Anna Keugenius, Livia van Vliet, Frederico Ramos. Some of you might know some of these people because they also spend some time at IS every now and then. I was also part of Odysseus, a large Horizon 2020 project. And in that project, we as social scientists and scholars in the humanities work together with mathematicians, physicists, computer scientists, and so on. So in the course of this project, we had many encounters on how you can use computational social science and complexity to better understand cultural conflicts and social processes. And in the course of my encounters with these different scholars, I learned about the intimate connection between computational social science and complexity. So this is where I want to, this is what I want to talk about. I want to talk about the connection between, on the one hand, computational social sciences as a collection of research techniques, methods, and so on. And on the other hand, complexity sciences as a specific ontology and epistemology of social life. And I want to develop the argument that if you adopt a complexity perspective, you gain certain benefits, but there is also a downside to it. And so this is what I want to explore in this presentation. And all in all, I think that you can summarize my mission by saying that I want to develop a different kind of computational social science, one that isn't premised on the idea that society is a complex system. So let me elaborate. What is exactly the relationship between computational social science and complexity? Now, if you read work in computational social science, you see that it's very common to describe society as a complex system. And this is an interesting proposition. For me, as a social scientist, it's also a somewhat provocative proposition. It's not self-evident that we should consider society as a complex system. And there's definitely very interesting, there are definitely benefits to seeing society in this way. So one very interesting development, I think, is that computational social scientists often look at relations rather than attributes. And there's a long history in sociology and social science generally to use surveys and to examine how particular attributes impact behavior. And then you get remarks like, if you have a low-class background, then your educational success is more limited. And so this is somewhat interesting, but it's much more interesting if you can actually study the interactions between people and if you can study emergent phenomenon. So this provides you with a much more fine-grained understanding of the dynamics of social life. So this is one reason I'm excited about this complexity perspective. Now, another reason that many people in the social scientists are excited about this is that it seems that there's a sort of perfect match between computational social science, complexity, and the proliferation of digital data. So the idea here is that with the abundance of digital data, it becomes possible to study social life in micro detail and to develop what some people call a physics of culture or a physics of society. And so if you use these sorts of metaphors like physics of culture or physics of society, then there's a sort of implicit assumption. And for some people, this assumption is actually explicit. And this is the assumption that the social sciences have never advanced to the same degree as the natural sciences. And that this is a very unfortunate circumstance, but that now finally the social sciences can catch up. Because now finally we have the digital data and we have the computational methods that put us on the same plane as the natural sciences.
Is that not true?
Yes, that is not true. As I will elaborate in the remainder of this talk. So Duncan Watts, for instance, has said that now that we have digital data, we finally have our telescope and we can finally have observations that allow us to understand social life in all its detail. And so what happens then is that social systems are equated with natural systems. But I would argue that there are fundamental differences between them and that societies and social life are even more complex than the complexity perspective allows for. So one reason for this is that social life is structured through meaning and that people have consciousness. So the repercussions of this are really fundamental. So the categories in social life and the agents in social life are not given, they're structured. So in any kind of social interaction, we always take on a certain role, a certain identity, and that role and identity is socially constructed. So for instance, if you would want to understand relationships, romantic relationships, we're not just studying mating behavior, we're also studying how people construe each other as suitable partners. and we can take on a manifold of different identities. Similarly, if we want to understand relationships between ethnic groups, we can't assume that the ethnic groups are just out there. The ethnic groups are actually constructed through interaction. More than that, they also think about this whole process. So there is consciousness involved. And that consciousness also results in reflexivity. And it means that social relationships are also laden with power. And so I would argue that because of this, we cannot expect to find the same sort of regularities in the social sciences as we can find in the natural sciences. The moment that you find a law-like pattern in the social sciences means that it becomes open, you open it up also for reflection and for adjustment. So if we find that, for instance, there is a certain mechanism underlying inequality, we cannot just observe it, we can also change it. And I would say that this is specific to human societies, and it means that they function in fundamentally different ways. So one way in which they function differently is that they change qualitatively over time. So there's not only quantitative change, not only gradual change, there's also qualitative change where people and societies are structured in a fundamentally different way. It also means that there's large variation in different types of social structures and even also within them. And so I would argue that this means that searching for universal mechanisms or universal laws, it's worthwhile. I'm not disparaging anybody who wants to do it, but I would say that probably you won't find many, and maybe also they're not the most interesting. Because if you want to study social life, you want to understand, for instance, qualitative social change. You want to understand processes like modernization, secularization, and so on. And in order to do this, I would say you need conjunctural and historical explanations. You need to consider how many different types of processes interact to produce a specific outcome. Now, all this is somewhat in conflict with the idea of viewing society as a complex system. If you view society as a complex system, you sort of assume that it has boundaries, you assume that interactions take place within it, and often you also assume that order is emergent, that it emerges from micro interactions. Now, all this happens, of course, in human societies, but there's also more going on. Social system.
I'm sorry, yeah. May I ask a question?
Mm-hmm.
Because this seems like generalizations that may be true for some complex systems, but I think I know many complex systems that don't behave this way. For example, in ecology, we're constantly battling the fact that this area of complex systems needs extensions to take into account history, to take into account the interaction between the historical perspective and the so to say the selection, the interactions between selective processes that are deterministic versus stochasticity that leads to a whole new world of, and I can go on and on. So it's very clear in ecology that complex systems needs to be extended to be able to capture other scenarios that are in other areas. But we wouldn't assume that complex systems or I should say differently, complex systems don't necessarily assume these features that you just listed.
Yeah.
I think.
Yeah, so I think I'm in full agreement with you. And I think just as you suggest that complex systems thinking needs to be extended to account for the specificities of ecosystems, I would argue that it needs to be extended, amended, reconsidered to account for the specificities of social life. I think I'm in full agreement, and I think it's also very interesting to consider the somewhat how do you say, ambivalent role of biology in all this, because I think biology does give us a vocabulary that can also be very useful for understanding social life. In part because it is very much focused on evolution, variation, and how that evolves over time. So this I find very interesting. Nevertheless, I would maybe go a little bit further even than you would. So I would say, well, you can extend the complexity perspective, but I'm doubtful that starting from the complexity perspective is useful in the first place. So I'm taking a more sort of hardline social science position, saying, well, we already have many social science theories, and I would say those need to be extended by incorporating computational methods and certain insights of complexity. But I would suggest that the qualities I just listed mean that the systems are, that social life is quite different, fundamentally different than at least a lot of complexity science would suggest. So I'm listing here also some
I'm
papers.
sorry I stopped you.
No. I'm happy if people interject with questions, so that I know how the message is received. So please don't hesitate.
Sorry, Justus, can I just continue on this? So is your point that the models have to be radically different? Like they just have to, you know, you're arguing that the way that people construct complex systems with agents, interactions, etc., that's just, you know, not the right way to start. You have to start from something else and then construct a completely different kind of model. Is that sort of what you're trying to say? Or?
Yes, that is what I'm trying to say, and that may seem like a very provocative statement for you, and I understand. But consider from my perspective, because there is already an established body of social science literature with many different theoretical perspectives. And so from the viewpoint of people who have invested in those perspectives and have developed them over the years, the idea that you would now have to change those perspectives and adopt a complexity perspective, that is a sort of provocation. So yes. I think what we're dealing with here is really sort of ontological, epistemological clash, and I also find this very interesting. So it's not for nothing that I have engaged with computational social science and the complexity perspectives over recent years, and I'm definitely also not hostile to it. So I think that the complexity perspective offers some very interesting insights for the social sciences. However, I'm here speaking for a complexity audience, and I think it is important, if I speak to that audience, to you, that I mention some reservations that social scientists may have about this perspective that you can ignore, take on board, or otherwise use to either reconsider or fine-tune your perspective.
Okay, but will you give some examples of this kind of models you have in mind, or starting with theory? All right.
Yes. Yeah. So I will give a number of examples from my own research. Now I don't start my own research thinking, how can I do complex systems differently? So in none of the cases, the research was designed with that purpose in mind. So, but what I did is I summarized some research findings, and I try to explain how the perspective I have is somewhat different from the perspective suggested by complexity. So I'd like to start actually by discussing one idea, and this is the diffusion of scientific ideas. And so that's one domain where the complexity sciences have really made a very powerful contribution. So this is the paper I'll be summarizing here very briefly, published with Anna Kagenius and Peter Turnberg, recently came out in Social Networks. And so in this paper, we study the spread of Granovetter's weak ties hypothesis. Now, are you familiar with this hypothesis? You're not?
No,
Okay.
no.
Okay. I won't explain it in detail, but I'll explain it as we go along. I sort of was expecting that at least some of you were familiar with it, and the reasons for that will become apparent very soon. So Granovetter's weak ties hypothesis basically suggests that people have different types of ties, or they have ties with varying strength. So they have strong ties, ties that you have with close friends, with family, maybe with some colleagues. And those ties are obviously very important. They provide you with everyday support. They provide you with hopefully love and affection. So those strong ties are crucial for your everyday life and for your survival. But Granovetter suggests that there's also a different type of ties, weak ties. And those are ties that extend beyond these strong ties. And they're very important, especially for reaching information that you would otherwise not have. So his classical example is about jobs. And he says that people get jobs and are alerted to job openings, not through their strong ties, but through their weak ties. And a number of scholars have developed this hypothesis in all sorts of different directions. And that is why we were interested also in the case. So this is basically the tension we started out with. So on the one hand, you have computational social science scientists, and they typically look at network structures of citations and collaborations, focusing on conditions of adoption. So this field has recently become known as the science of science, and a number of prominent physicists especially have sort of revolutionized the study of scientific development. And they especially are interested in this question: why do, or when do, under what conditions do people adopt certain IDs? So I find this research very interesting, and we also used it to inform our paper. But there's also some limitation to viewing scientific diffusion in that way. Typically, computational social scientists model scientific diffusion in terms of contagion, and they feel it is somewhat similar to an epidemic, where in the end everybody adopts a certain ID. If you look at qualitative research on scientific diffusion, it has a completely different perspective. It looks at interpretation and meaning, focusing on creativity and adaptation. So one study we cite is about Feynman's diagrams, and there's this a book by Kaiser on it, showing how different generations of physicists interpret the diagrams in completely different ways and use it to structure their research in qualitatively different ways. So they focus more on adaptation. And so we wanted to bring these two approaches together in what we call a computational case study. So it's computational in the sense that we use advanced computational methods, but it's also a case study in the sense that we want to understand in detail the interpretation and the creative work that goes into scientific diffusion. So we study both adoption, when do people learn about Granovetter's hypothesis, and we study adaptation. So we're interested here in the first references to Granovetter's strength of weak ties, the first references of an author, because we argue that is the moment that you adopt the hypothesis in your own work. And we constructed what we call a diffusion network. So we draw edges between authors that are cited in the piece in which Granovetter is cited. So if I cite a piece with Granovetter's hypothesis, and I also cite J, then there's an edge between me and J. And the assumption is that I interpret Granovetter's hypothesis in part through J's work. So this gives us a diffusion network of over 15,000 scholars, about 140,000 edges. And that shows us who adopted the hypothesis when. So this is really about adoption. And then we also did topic modeling and we did close reading because we also wanted to understand how authors interpret these ideas. So this is the diffusion network. And you immediately see that there are different communities that adopt Granovetter's hypothesis. So these are the communities. I won't discuss them in detail. I'll only mention the first three. So the very first one is a community of mostly people in business and organization studies. The second community is mostly composed of social scientists interested in survey research. And the third community will be most familiar to you. It's composed mostly of physicists and computational social scientists. So, and these different communities, they adopt the same idea, but they give a completely different meaning to it. So this is the first community.
Sorry, can I just ask a question?
Yeah.
So these names you highlighted there, they just show up more on the citations? Is that why you chose these specific names there?
The central figures, you mean?
Yes, yes, yes.
Yeah, so they are central within their communities.
Yeah, so they show up more as being referenced.
Yeah.
Yeah, okay, okay.
Yeah. So this is the first community of business and organizational scholars. And they interpret Granovetter's idea in the context of innovation. So Ronald Burt is an important scholar here, and he develops his own argument, the structural whole argument, that draws on several lines of network theorizing that emerged in sociology, most notably Granovetter on the strength of weak ties. So for Burt, the strength of weak ties is really about innovation. So he is interested in the network structures where innovation can occur. And he develops this notion of structural wholes, the space within communities, and he argues that that is where innovation occurs. Now, community two has a completely different understanding of weak ties. They don't see it as a network property or as a structural whole. Instead, they see it as an individual attribute. And so here's Lin and Damin, who argue that for two individuals at the same or similar initial positions, it is hypothesized that the one who uses weak ties rather than strong ties will tend to reach better social resources. This is called the strength of weak ties proposition. But this is a completely different type of proposition than we heard before. So it's the same hypothesis, but it's interpreted in a different way. And I just use this to hammer home the point how different this is. So here they really talk about social networks being the property. And even if other people use those networks, then still it remains the property of the friend or his or her friends. And so community three has, again, a very different understanding. So evidence in support of strength of weak ties hypothesis has suggested that networks with high levels of local clustering and tightly knit neighborhoods are inefficient for large-scale diffusion processes. So here it's not about individual attributes and how individuals might benefit or not from strong or weak ties. Here, weak ties are a network property. So we also looked at how these different communities evolve over time and according to what logics. And so here's the overall network.
Can I ask you a question just before you? Oh, now I got a blackout. Doesn't happen that often. Can you go to the previous slide just to
see if it comes back?
Yeah, right. So these quotes you have are representative of the. So are they representative of those communities? How do you? Yeah. How do you? Yeah, extract this quote out of as a representative of the community. Yeah, that's. Yeah.
Yeah. So Sentola is one of the very central figures in this community, as you can see here. Oh no, he actually doesn't light up so much, but yeah, now he's there above Balabasi and Laser. So what we did is we looked at the authors who were cited the most and the articles that were cited the most within specific communities. And so none of these quotes are representative, of course, of the community as a whole, because the community includes over 1,000 scholars and many hundreds of articles. But arguably, these are the most representative quotes. And we also, of course, read many other articles, and we did topic modeling on the abstracts of all the articles. So this gives us a sense of the way in which the hypothesis is interpreted and framed. And I use these quotes to illustrate how people within those communities speak. And so I would argue that this is indeed fairly representative for how people in the third community speak about weak ties. They would not say stuff like this, nor would they say stuff like this. So in that sense, it is representative.
Thanks.
So in conclusion, we were interested in adoption and adaptation. And I think that is crucial, because the moment that you also consider adaptation, you open up a whole different world. It is not just about the spread of something that remains unchanged. It is about the spread of something that changes as it spreads, and that changes through reflexivity, that changes also through meaning, and in the end also partly through power dynamics. So this has it is a subtle difference, but it's a very important difference, because it shows, I think, how you can incorporate meaning and creativity in a complexity perspective. Now, what we also showed, but I won't go into it too much for reasons of time, is there are really very different community dynamics. So for instance, the third community I described is constituted in a very different way than the others. It grows much faster. It is also more centralized than the others. And so this type of variation I find very interesting. So rather than looking for one universal mechanism of community formation or diffusion, we focused more on differences between communities and also different roles that authors take. So in this sense, it's very interesting, for instance, to compare Ronald Byrd to Balabasi. Whereas Ronald Byrd sits in between different clusters, Balabasi is really the champion of the cluster of physicists. He's almost exclusively cited from within his own community. So he fulfills the role as a champion, whereas Byrd more has the role of a broker. Now, apart from all the details, I think that this shows that this is a slightly different way of doing complexity research, where there's more focus on meaning, on reflexivity, on variation, on historical development. So it is, you might say, complexity extended. Now, for my second example, and I know I need to hurry up a bit, it comes from urban research. And so it's about understanding urban segregation and inequality. And this is one domain where complexity sciences recently made a number of contributions. And typically, the assumption underlying complexity perspectives is that patterns of segregation result from self-organization. So one very well-known model is that of Schelling, who looks at preferences of agents and then looks at how they interact. And he then sees the macro patterns of segregation as an outgrowth of these micro interactions. Now, I find that model very interesting. And I find it interesting also as a thought experiment, because he shows that even with minor differences in preferences, stark patterns of segregation can result. And so this is an important finding.
Yeah, I ask a question again.
Mm-hmm.
So at least in my area, but also in others in systems biology and so on, there's a lot of work being done on the relationship between pattern and process. And so patterns is what we see, and we don't know the processes, of course, and different processes can lead to similar patterns, which is the challenge, of course. And so an immense amount of work is actually, invested in trying it. Once you see a pattern, like you say, emerging, segregation or whatnot, you really cannot know if it's a matter of intrinsic processes that would lead to that pattern, or if it's some sort of environmental situation, or if it's, what drove these patterns, which is also one of the challenges with big data these days, because big data is really looking at patterns without considering, where these processes came from. But are you sort of saying that by default in sociology, when you see a pattern of segregation, people would automatically decide, conclude that this is a process that's self-organized?
Well, it depends on how you view self-organized, but no, I think the short answer is no, absolutely not, no. And this is also, I think, a difference between, say, mainstream sociology and some work in complexity that is presently being done. Like complexity researchers often model segregation based on certain assumptions, and then show with their models how under these assumptions certain patterns emerge.
They say, right, they show that it can emerge, but they could never claim that that is the source. And there's there are plenty of, if a person comes and says this is the model explaining this pattern, then that's wrong, that's bad science.
Yeah.
And everyone knows this. I mean, even the motif types of, I can say for my first paper, I remember criticizing people saying that motifs in networks are an outcome of evolution, and I very easily showed that physical constraints would lead to different frequencies of motifs as well. But you can't claim that the fact that you have a good fit, that's the reason, that's the mechanism.
Yeah, no, I find myself in complete agreement, and so this is also one of the issues I have with, say, sloppy complexity science, because not all complexity sciences would do this. But if you would reconstruct a certain pattern that you observe in real life under certain assumptions, then obviously that doesn't mean that you explained it. I mean, you just reconstruct it.
Right, exactly.
And so that may also lead you astray, because you might actually think, okay, well, now I understand how that system works, and if I'm now going to tweak that system a little bit, a different outcome.
But that's bad science.
Results. Yeah, it is.
I mean, the
science.
usefulness of these types of models for reconstructing a pattern is that based on these models, you can actually then design experiments to see if there's agreement between the data you collected or the experiments that you did outside to what you would expect if you do these experiments with a model that's making these. And if you see a difference between them, you know that this is not the good reason, but they're actually, you could call it model-generated fieldwork or model-generated empirical studies.
Yeah. So that's one way to work with models. Actual real-life experiments in this particular field of segregation are probably not possible. So then models take on a somewhat different role, more as a thought experiment that shows you what happens under certain assumptions. And I think that's useful, but it's useful only as a thought experiment. And I think my main argument here is that if you look at a lot of recent work on cities, it starts by saying cities are like organisms. They grow out of micro interactions. And so there's also comparisons, for instance, of cities to ecosystems. And I think that's all helpful, but up to a point, because we have to understand here that these are metaphors. that cities are not like ecosystems in some fundamental ways. And so one way in which they're different is that people actually reflect on the system that they're creating and subsequently intervene into it through very conscious policies. And so I would argue that that makes cities fundamentally different.
But
and so
would
then
it make it different than a complex adaptive system?
They make it what?
Complex adaptive systems are systems where the agents are, they change their behavior based on the interactions.
Yes. So I'm not sure also if the word complex adaptive system solves this problem. So for me, the question is it useful?
The agents learn. I think that's the usual definition. Sorry, yeah.
Yeah. So is it useful to view a city as a complex adaptive system? I think for some purposes it might be, but for other purposes it might not. And so here I think again, as in my earlier answer to Jade, we're in a somewhat different position, because many of you are already in the complexity corner. And so for you, the question is like, okay, I have a complexity perspective. Can I then also apply this to the understanding of, say, cities? So for me, I'm in a somewhat different position. So then the question is it really useful for me to view it this way? Or do I then import all sorts of assumptions, biases, premises that I may not really want? And so if I look specifically at the case of research on cities, then I see that what often happens is that complexity perspectives on cities emphasize sort of the self-organizing qualities of cities and downplay the role of, for instance, political economy, or downplay the role of policy. And so in that sense, it's not that they're wrong. I mean, they just downplay certain aspects. It's just, for me, the question is it strategic to adopt them? Does it help me understand cities the way I'd want to?
Yeah. May I be a little bit provocative now?
Mm-hmm.
So the transition of the social sciences into proper sciences, where you actually have a scientific method and you're actually conducting a scientific research, where you would be using both empirical and model-based approaches to feedback on each other. It sounds to me like you have, because I agree with all the examples you're giving, but it sounds to me like you have an open, or how should I say, an open turf here with the use of science and the models in the social sciences and how they're being done. It sounds like they're not being done properly. Rather than with complex systems, because to me, complex systems is just a term it's like a modeling approach. And it's also one of these things that I would constantly say to my students, and you don't fall in love with your model. Always be aware that your model gives you a way to understand, but it also confines the way you understand. If you get too attached to your model, you start seeing a system the way the model tells you to see it, rather than the way the system is itself. These are all things we teach our students in courses like the empirical cycle or complexity and simplicity and so on, about the correct use of models in science, and also just generally about, a scientific process. I'm not so sure why the focus is necessarily on this turf of complex systems. It just seems like another set of models. And also there, we would need to check, is there nonlinearity? Is there, so on and so forth. You can't just assume it's there.
Yeah, no, so I find myself in agreement, except that maybe you think that you criticize social scientists and how they're not transitioning into proper science, whereas I'm actually criticizing work that I see being conducted by physicists and others on cities. So the idea that you shouldn't fall in love with your model is, I think, something that we should all put on our wall as a constant reminder. but it is my impression that this tendency is more prevalent among people who are used to having their models work very efficiently. And those are often natural scientists. And what you describe as developing models, using empirical data to test them, revising the models accordingly, and that is of course something that has been happening in the social sciences for decades now, about 150 years or so.
Of course, I wasn't coming out against the social sciences, but I am getting an impression that there is a lot of criticism about the way the assumptions being made, the way that, and I have the same criticism for areas that are close to me. I do think many students are not learning philosophy of science properly, are not learning scientific methods properly. I think most people around me, even though I'm a theoretician, I'm a modeler, do not know what models are for. They use them incorrectly. And I do think also that many people coming from, and forgive me, the rest of the people here, but I do think many people coming from physics have a very distinct way of seeing modeling, which many times is not relevant for areas that I come from.
Yeah, well, yeah.
But they don't dominate all of complex systems. They're just one. They're just one corner.
To be provocative, but
they're just one corner in my view.
Yeah. No. So maybe it is my mistake in communicating my ideas, but this is actually what I wanted to say. So and that if you adopt this complexity perspective, maybe somewhat naively, then these are the mistakes you're quite likely to make. And specifically looking at cities again, if you take a complexity perspective, then I would argue, seeing the research that presently comes out, that there is a tendency to overemphasize the self-organizing nature of cities, to overemphasize also regularities. Whereas I feel that it's important, if you want to understand cities, to also include qualitative variation, to include power, and also to include institutions. So this is what I wanted to illustrate for my next example. And I think that we have about 7 minutes, so I need to find a way to do this super efficiently. So,
you can take a bit more if you need. There's not a problem.
Okay, thank you. So in this study that I did with Cody Hossenbach and Jolien Groot, we wanted to actually understand how policy impacts segregation and urban inequality. So we looked at Amsterdam and Rotterdam. We used register data on households and dwellings. So this is what is often now known as micro data. So we have information on people's income, where they live, and when they did so. And we specifically constructed a database of dwellings. And we compared different parts of the housing stock using that database on dwellings, because we could see in our database whether a house was demolished or constructed, or whether it was converted from rental to ownership or from ownership to rental. So this is very valuable to us, because now we can see how different parts of the stock that are subject to different interventions contribute in different ways to urban inequality. And so we looked at different kinds of spatial inequality. First, segregation, do people live in the same neighborhood? But also status inequality. What is the status of the neighborhood that people live in? Is it true, for instance, that poor people tend to live in neighborhoods that have low status, that are not valued very highly, or not? And we looked at exclusion. Are people able to stay in or enter the housing market at all? So this gives you an idea of the dominant interventions. I'll focus only on Amsterdam for time's sake. So on the left, we can see that in the historical center, and especially in the 19th century ring surrounding it, many dwellings have been converted from rental to ownership. And on the outskirts, in the peripheral neighborhoods, we see that demolition and construction is more common. And so our question is, how do these different interventions influence urban inequalities? So I'll race through this, but here we can see on the left that the highest incomes increased by far the most in almost all parts of Amsterdam, and that low income groups saw their share in the population reduced. And so we were able to link this directly to these policy intervention by comparing different parts of stock. So, okay, I'm trying to find a way, because this is a long story to be short. So if we look at segregation, do people live in the same neighborhood? We find that the impact of the policy was actually to reduce segregation. So people are now mingling more than before. Low income groups, high income groups live more in the same neighborhoods. And so this is also, segregation is also what people, whether in complexity sciences or not, generally look at. So segregation is sort of the main concept. But we also wanted to know what neighborhoods people live in. Are these valued neighborhoods, or are they neighborhoods that are not valued? So we looked at status inequality. And so what we find is that neighborhoods in Amsterdam, as probably you all know, are very different in terms of status. So the center, the historical center, the 19th century ring, and areas within the ring road are valued much more than areas outside of the ring road, New West and parts of North and parts of Southeast. So this gives you an indication of the status of different neighborhoods in Amsterdam. And so then we wanted to know, do poor people, are they pushed out of valued neighborhoods? And we found actually that there was very little impact. This is not what we expected, but so there was hardly any change, zero change even in Amsterdam. But this is interesting, especially in the contrast with segregation, because we found that people were mingling more. And so you might say, that's good. Rich people and poor people live in the same neighborhoods. But it doesn't mean that poor people now live in neighborhoods of a higher status. And then finally, we looked at exclusion. Now, don't be afraid. This is a very big table. But here we can see the changes in income groups in different parts of the stock. So it starts with change overall. And then we can see that the lowest income groups and low income groups and medium income groups saw their share decrease in Amsterdam. And we can also see where they saw their share decrease the most. Is this in neighborhoods of low value or neighborhoods of high value? And then we can see the impact of different types of policy measures. And we see that both demolitions and constructions, as well as conversions, resulted in a lower proportion of low income groups, a lower proportion of medium income groups as well. So this allowed us to say that due to these policy measures, or at least after the policy measures took place, low income groups were displaced and high income groups and higher income groups took their place. So conclusions. First of all, I admit that our findings are not so spectacular. To be honest, we expected more segregation, we expected more status inequality, and we also expected more exclusion. But they illustrate the importance of distinguishing multiple dimensions of inequality. So not only to look at segregation, not only to look at status inequality, not only to look at exclusion, but to look at all three of these dimensions. And I think this is important because urban research generally has focused very much on segregation, on the question whether people live in the same neighborhood. Whereas for many people, an important question is also what kind of neighborhoods are they living in? Is it a good neighborhood or a bad neighborhood? And obviously, an important question is also, can they live in the city at all? And so our findings do suggest, and this goes against some policy ideas at least, that actually the lowest income groups and the low income groups suffered the most from Amsterdam's housing policy. So they were displaced. And this is also true to some extent for medium income groups, but high income groups and the highest income groups benefited the most. They occupied the dwellings that were either converted or constructed. So I had to race you through these findings, but I think it shows more broadly how planning and power shape microdynamics. So I think that this illustrates that it's important also not just to look at segregation as self-organization, but to also examine how policy shapes different parts of the housing stock and as a result, patterns of segregation. I'll skip this. So overall conclusion. Now, after this presentation, you may get the impression that I am a staunch opponent of the complexity perspective. I guarantee you that this is not the case. Within my department and within my circles, I'm known as a staunch defender of the complexity perspective. It is just that that complexity perspective is much less popular within my circles than it is within yours. And I find it an interesting perspective because it offers powerful methods and powerful tools. And it also helps us identify certain mechanisms. It helps us through modeling to engage in thought experiments. So this complexity perspective, I think, is helpful, but it can also lead us astray. And as Yael mentioned, it is not that this is a necessity. If you use your models properly, then obviously you can engage in very good science. You don't have to make the mistakes I just mentioned. But what I do want to argue is that if you look at social life through the lens of complexity, you're likely to see some things, but you're also likely to miss some things or to downplay some elements. And so these elements are meaning, consciousness, power, planning. These sorts of dimensions easily get lost when you develop a complexity perspective. Not necessarily, but there's definitely sort of bias against incorporating these sorts of dimensions. And these happen to be the dimensions that are most distinctive for social life, which is why I think it is important that complexity scientists take them seriously. And so I would also argue that we can use computational methods, computational tools, but we can also ground them in different types of ontology. So for instance, within sociology, there's the field perspective of Bourdieu, a very powerful, proven way of understanding social life. And I think it is possible to incorporate computational methods and models into that perspective. So you don't necessarily have to adopt a complexity perspective to use computational methods. And it can be very interesting to try to recombine them in different ways. So I'll stop here. Thank you very much for your attention and your engagement.
Thanks. I hope we have time for some questions, maybe. Yeah. If someone, yeah, go ahead, Jan. Yeah.
Yeah, I'm not sure what my question is, to be honest, but I guess we call ourselves the Dutch Institute for Emergent Phenomena. And that's maybe slightly different than what is sometimes referred to as complexity. And there the whole point is that there are certain emergent phenomena and to identify whether we can find the main drivers, the main sources, the main collective variables, and so on of these phenomena, which may or may not be of what you refer to as the complexity perspective. And I think this notion of the complexity perspective, to me, I don't know exactly what it is. I guess Jan also made a few points that this is not a very well-defined thing. It looks to me like everything that you were saying is part of this general phenomenon of looking at complex systems and and complex dynamics, collective dynamics, and trying to figure out what the main underlying causes are, what are the main drivers of these phenomena. And if you have a certain model and you say that policies are the most important feature, then you could either do an experiment and take 3 cities in Holland and have 2 policies in one place and a different policy in a different, and see what happens. It's usually quite difficult to do these experiments. But your interpretation of this concept of complexity perspective, is that based on a certain community that you observe and that you feel like are leading the field astray? Is that where this whole notion comes from? I'm trying to engage a little bit. Maybe let me phrase a question. What exactly is the definition of the complexity perspective that you're using in your seminar?
That varies, obviously, depending on the research field. But if you look at research into public debates, it would be opinion dynamics. So I would say that opinion dynamics, as a sort of subfield, is very much informed by a complexity perspective. And so it has specific methods. It has specific patterns that it's interested in. And it is also very different from some other social science understandings of public debate. If you look at cities, then I'm thinking of work by Jeffrey West, Betancourt, to some extent Michael Beatty. And so they would also have an understanding of cities as complex systems with emergent qualities that are structured through self-organization. So these are sort of the people I had in mind.
Right. So your what you refer to as the complexity perspective is very much like an autonomous network that is not steered by external forces, but has a few simple rules of interactions and communication, and then somehow that is the main driving force behind these phenomena. Is that what you refer to as the complexity perspective?
I think that's a fair summary, yeah.
Oh, I see. Okay, good. Yeah. I think there's also some semantics discussion of what we call complexity and all of this. That's why, just to be free of all these issues, that's why I think deep is maybe a better word for this type of research than.
Yeah, no, it's. I thank you for pushing me to sort of better define what I'm talking about when I talk about the complexity perspective, and I think it's partly has to do with the format of a talk. I mean, you have to just say, okay, this is the perspective I'm talking about, and it is almost inevitable that you have to trivialize what they say to some extent. There's also something else that is going on that is maybe more interesting, that some of the issues that I pointed out are actually recognized by complexity researchers. And people are trying to revise their models and their approaches to take those issues better into account. And so these are interesting developments of which I may not be fully aware, but I would definitely welcome that. And maybe in that sense also, the idea of beyond complexity is a better one than limits to complexity.
Are there any more questions? Well, I have one.
Yeah.
Okay, go ahead.
No, please go ahead.
Okay. No, well, it's not a big question, but so the first study you showed of this sort of spreading of the weak ties idea, is that something? So are you thinking in now doing some similar analysis for other ideas, or you just proved your point with that single thing, or can we give you an idea that maybe is worth also checking? I'm specifically thinking about the the most well-cited paper in theoretical physics that from the 90s, which is about the idea of holography, has more than 20,000 citations by now. I was just wondering whether there's any value in trying to apply this method to these kind of ideas. Yeah.
I absolutely think so. And in fact, Anna Genius, who's my PhD student, also studied the concept of intersectionality in this way. And so that's obviously a very different example, but it's also similar in the sense that it's a scientific concept that diffused throughout the academy and is reinterpreted in different types of community. And I think that's extremely valuable because it shows you that when people use the same word, they can mean very different things and use it for very different purposes. And the example that you just cited, yeah, you could study in the same way. And you could also do a study like this on the complexity perspective itself. I don't know right now the technicalities of how you would do that research, but you would definitely find that there are many different understandings of complex systems. And so that would also help someone like me to better specify exactly what type of complexity thinking I'm talking about. I think that Lassagerets and Castigliani are presently doing something like this at the IS, looking how different communities reinterpret complexity and use it in different ways.
Thanks. There's some discussion going on in the chat. I don't know if someone is. Yael, maybe you.
I was just noting that I think, and I may have been overgeneralizing, but many times people coming from a more physics approach would be looking for fundamental laws, whereas this isn't many times the approach in other areas of complex systems and other fields and other disciplines. So I was just commenting because you'd mentioned fundamental laws and you'd mentioned that approach of this very deductive coming from simple rules and going from there. Yeah, I think it's again this discussion about what is complexity. Is complexity really something that has to have fundamental laws? I think that's that's a very particular discipline within complexity that has that.
Yeah, no, and I think again I find myself very much in agreement. So, but what you now see happening within certain corners of the social sciences is the idea, and this is what I started my talk with also, the idea, now we have computational methods, now we have digital data. This makes us very much alike physics, which will now also allow us to become a sort of physicists of social life, finding regularities, finding universal laws, finding universal mechanisms. And so this is a tendency I'm somewhat skeptical about.
But now I remember what I was going to say. I was going to say that in the beginning of the epidemic, beginning of the pandemic, there were many physicists conducting, rediscovering the SIR model and having these exponential fits. And it was all very useful for these very, very first stages of the epidemic. But it was quite clear for an epidemiologist, I've been dealing with epidemiology quite a bit, that once we start dealing with questions of immunity, questions of reinfection, questions of, and so on and so forth, not to mention questions of evolution of new strains, or I should say new variants, all these basic methods of fitting and finding the R naught, the very first month of an epidemic, become completely useless. And these SIR models that were used in order to try to optimize different closure methods, you know, people working for 2 weeks and not working for 2 weeks, and we'll interchange them. It worked beautifully for that very initial stage. It would become completely irrelevant within 6 months, completely clear. You know, it was sort of funny to look from the side, seeing them have a field day, see them get all the press and the media and all these models, like the first time they discovered the SIR, and then it becomes irrelevant. And we see that now. So yeah, for me, this area of complex systems is actually the rest. But I suppose it's also a way of viewing how we do our science.
Thanks. Are there any more questions? No? Okay. Thanks a lot, Justus. It was an amazing talk and nice discussions. Yeah.
Okay. Yeah. Thank you very much
Yeah.
for hosting me, and thank you very much for the discussion.
Yeah. Okay. See you.
Bye bye.
Right.